On number 43, it says a girl was walking home at a steady pace. Then she stopped to talk to a friend. After her friend left, she jogged the rest of the way home. And we're sketching a graph to model the situation. So we're looking at distance over time. Straight. Okay, so when she's walking at a constant pace, it's straight. Then she stops to talk to a friend, so it drops. Then she jogs home, so what happens? So then it increases. Okay. So constant, stops to talk to a friend, starts jogging home. Is this continuous or discrete? Okay, why?
Because it
What's the definition of a continuous graph?
keeps going.
Keeps going, right? Connected lines. We have connected lines. So if it's continuous, it's connected lines. If I look at 44, a ball is dropped from a second-story window and bounces to the stop on the patio below. So we're starting up here at a second-story window, and what's happening to our ball? It's going down, we're dropping it. And then it's going to bounce. It says it bounces on the patio, so you're going to get a graph that looks something like that. That's fine. Okay, so is that continuous or discrete? Continuous. Okay, why? Because it's connected. Connected lines, connected. I know, so it's connected. It's just one. Okay, so continuous graphs, connected lines. What does a discrete graph look like? It's dots, yeah, it's just discrete points. So, discrete graph is distinct points, they're just dots. So like 45, so if we look at 45, 45 is a discrete graph because it's just dots. There's no connected line. So if I look at 45, we're writing a possible situation for the graph. So what is a possible situation for that graph? Oh, we're talking about the number of fish. The number of fish swimming up.
Fish had babies.
Fish had babies, okay? Or we're adding 2 fish. We're buying new fish. So fish had babies. The number of fish is increasing, right? The number of fish is going up. So we can say fish had babies. We can say that we bought new fish every 2 weeks. We can say we bought 2 new fish every week. Either way, our fish are going up.
Miss Deal looked at me like
No, don't look at people like that. Okay, if we are then looking at 46, we're looking at height over time.
I put arrow 3 drops.
Okay, and then what happens?
And then get time to
Okay, so drops, then it goes up, then it stays the same. Because right here, you're dropping. Then you're going back up, then you're staying the same. So that's why you have those 3 different things happening in that one graph. So are we good on 46? Okay. 47, 48, and 49 are the same, so I'm only going to do one of them. Which one do you want me to do? 48. Okay. So if I look at 48, it says express each relation as a table, a graph, and a mapping diagram. Give the domain and range of each relation and explain whether the relation is a function. So we have 6 things that we're going to do on that one problem. We're going to do a table, a graph, and a map to start with. So if I start with a table, I know that my first value in every set of ordered pairs is my x. My second value in every set of ordered pairs is my y. So if I make this table, then my first numbers are going to be -2, -1, then -1, 1, 2, 2, 3, and 3, 4. Those are your first numbers that should be in your table. The next thing we're doing is we're making a graph. Okay, so on my graph, I'm going back 2, down 1, that's my first point, negative 2, negative 1. Then I'm going back 1, up 1, that's my second point. Over 2, up 3 is my third point, and over 3, up 4 is my last point. So your graph should look like that. Then if I make a mapping diagram, that's where I use those two bubbles and I connect them. So my x values are negative 2, negative 1, 2, and 3. My y values are negative 1, 1, 3, and 4. I then map my numbers to them. So negative 2 maps to negative 1. Negative 1 maps to 1. 2 maps to 3, and 3 maps to 4. Okay, so we good on a table, a graph, and a mapping diagram. Those are the first 3 things you do on the problem. Okay, next it asks to give the domain and the range. Okay, so what values does my domain refer to? X's. Okay, so if I look at my mapping diagram, that's what I'm going to use. Then my X's are negative 2, negative 1, 2, and 3. What values does my range apply to?
Negative 1, 1, 2, 4.
Very good, my Y. So negative 1, 1, 3, and 4. Okay, and then the last thing it asks us to do is to decide if this is a function. And so we tell if it's a function by looking at our mapping diagram. So I'm looking at just my x's in my mapping diagram. If I look at just my x's, do I have more than one arrow coming out of any of my x's? No. And so then, yes, this is a function. So those are the 6 things that you're going to have going on that one problem. So any questions on 48? Alright, so then I told you we're going to skip 49 then. So let's look then at 50. So if I look at 50, I'm given the table x, y, where x is 1, 2, 3, and 4, and y is negative 6, negative 5, negative 4, and negative 3. And I need to determine the relationship between the x's and y's. First thing I always try is multiplication or division. So I take my x value and I'm doing something to that x to make it equal my y value. So if my x value is 1, what do I need to multiply or divide 1 by to make it negative 6?
To divide by, or multiply by negative 6.
Multiply by negative 6. Okay, now I want you guys to test that for 2, 3, and 4 and see, does that work out for 2, 3, and 4? If we multiply 2 by negative 6, does that work? Okay, so that doesn't work, so next we need to try addition and subtraction. Alright, so if I try addition and subtraction, we're taking my x, we're doing something to my x to make it be y. So 1, something to that to make it y. So what do we need to subtract? Subtract 7. Okay, if I do that for 2, does that work for 2?
Yeah.
Okay, does it work for 3?
Yeah.
Does it work for 4? Okay, so if it works for all of them, then we pull that minus 7 up top and say x minus 7 equals y is my function.
And multiplied by.
Yeah, so if we look at 51, let's try to do 51 in our heads. We're in the table 1, 9, 2, 18, 3, 27, and 4, 36. Raise your hand if you can figure out what you need to do to that 1 to make it be 9 and that 2 to make it be 18. Think really hard. What would we have to do to 1 to make it be 18? That could be the same thing we do to, or to make it be 9, to do the same thing we do to 2 to turn it into 18. And we're going to we're going to either multiply or divide, or we're going to add or subtract. Oh, did I? Darn it. Okay, so we're going to have to make 1 turn into 9, we have to multiply by 9. To make 2 into 18, we have to multiply by 9. To make 3 into 27, we have to multiply by 9. And to make 4 into 36, we have to multiply by 9. So we could do that in our heads if we just looked at what we needed to multiply or divide or add or subtract from 1. So then my function is x times 9 equals y, or you can write it y equals 9x. Either one would be correct.
Why?
Alright, on 52, we're identifying independent and dependent variables and writing a function in function notation. So we're told a baker spends $6 on ingredients for each cake he bakes. So we're talking about money and we're talking about cakes. Which one is going to be my independent variable? Let's see if we remember it.
The dependent, yeah,
Okay, so then what's my independent?
no.
Money, right? Money's my independent. So I have independence amounts of money, that's that $6. So my dollars is independent, and my dependent is cakes, and then I need to write a function in function notation. So f of x is function notation. So I have $6 per cake. So how would I write that as an equation? 6, okay, 6 times x. Very good. So f of x equals 6 times x, or we can write this just 6x. So f of x equals 6x. Either one would be correct. So any questions on 52? Okay, skipping to 54. Graph each function for the given domain, and we're given -2, -1, 1, and 2. So if we're given the domain, then that's our x value. So I know that for my x values, I'm going to use -2, -1, 1, and 2. So if I plug that in for x, I get, what is 4 times -2? -8. So I get -8 plus y equals 2. So how do I solve that for y? Plus 8 plus 8. So what does y equal? So y is 10. Okay, if I plug in -1, 4 times -1 is -4. So -4 plus y equals 2. So what does y equal? 6. If I plug in 1, 4 times 1 is 4, so 4 plus y equals 2. What does y equal? -2. And if I plug in 2, 4 times 2 is, so 8 plus y equals 2. So what does y equal? -6. So I get -2, 10, so back 2, up 10. negative 1, 6, so back 1, up 6. 1, negative 2, so over 1, down 2. And 2, negative 6, so over 2, down 6. Do I connect those points? No, why not? Because they gave us a domain. Very good. So when they give you the domain, you do not connect your dots. All right, so out of 56, 57, and 58, which 2 do you want to do? 57?
They give you domains.
You don't connect your dots. Okay, so I got a 57, so then 56 or 58, which one of those do you want to do? Out of 56 or 58, which one do you want to do? Do 56, so we're going to do 56 and 57. Okay. So 56. 3x minus y equals 1, and we're copying the function. Since they don't give us a domain, we get to pick our own. So what do you want to use for your x's? 1, okay, what else?
7.
2, and 7, okay. So 1, 2, and 7. So if I plug in 1, 3 times 1 minus y equals 1. 3 times 1 is? Okay, so 3 minus y equals 1. So what do I need to subtract from 3 to make it be 1?
2.
2. So I'm going to get 2. Alright, if I plug in 2, 3 times 2 is?
6.
Okay, so 6 minus something equals 1. What do I have to subtract from 6 to get 1?
1. Or wait, 6. I mean 5.
5. So the next one is 5.
And the next one is 6.
And if I plug in 7, 3 times 7 is?
21.
21, so 21 minus y equals 1. What do I have to subtract from 21 to make it be 1?
20.
20. Okay, so then if I graph that, over 1 up 2, over 2 up 5, over 7 up 20 would be somewhere way up there. So we'll just leave that one off our graph. So then do I connect these points?
No,
Yes, okay, why?
because they don't give us a domain.
Because they don't give us a domain. So we connect our dots when they don't give us a domain. Alright, and then the next one we said we were going to do was 57. So, if I look at 57, what values do you want me to use for my x? Negative 2, okay, what else? 3, and 1 more. 4. Okay, so negative 2, 3, and 4. Those are my values. So if I plug in negative 2, 2 minus the absolute value of negative 2. What's the absolute value of negative 2? Positive 2, and 2 minus 2 is 0. If I plug in 3, 2 minus the absolute value of 3. What's the absolute value of 3? 3, and what's 2 minus 3? Negative 1. And then if I plug in 4, 2 minus the absolute value of 4 is negative 2. So I get negative 2, 0, so back 2, up 0. 3, negative 1, so over 3, down 1. And 4, negative 2, so over 4, down 2. That's kind of a funky looking graph. Alright, so then do I connect my points? Okay, so I'm going to have something that looks like that. Alright, so do we have any questions on 57? No. Okay, so let's get 58 and we'll look at 59 next. So So if I'm looking at 59, I'm looking at graphing a scatter plot, okay? And it says graph the scatter plot for the, using the given data and describe the correlation. So I'm going to put my years on the bottom. So 2000, 2001, 2002, 2003 are going to go on the bottom. Then I'm going to put my values on the sides. And I have values that range from 20 to 28, so I'm going to go by 2. So 20, 22, 24, 26, and 28. Okay, remember, scatter plot is just an estimate plot. So we're just kind of estimating where these are at. So if I go to 2000 and then I go up to 28, that's my first point. 2001 corresponds to what number? What number corresponds to 2000? 2001, which number corresponds to that? What's my value? 25. So I'm going to go up to 25. For 2002, what's my value?
23.
23. I kind of need to help me out with the next one, okay? 2003, what's my value? Oh, that's okay. 2003, what do I get? What is my value from my graph? 20. Okay. Do I connect these points?
Yes.
No, you never connect scatter plot points. So you're never going to connect points on a scatter plot. But we do have to describe our correlation, and we learned 3 different types of correlation this semester. So Niles, what's one type of correlation that we learned? No, that's not a correlation. Correlation describes what our graph is doing. If our graph's going up, what type of correlation is that? Do you remember? Starts with a P. Yes, we're still waiting for you. If our graph's going up, what type of correlation is that?
Yeah, you can.
Positive. One type of correlation that we learned is positive. Okay, what's another one where our graph's going down, Kyle? Negative. Okay, and Ethan, what's the one where the points are all over the place? It starts with an N. None. When we have points all over the place, we have no correlation, okay? No. Okay, so what are our points doing in this graph?
Negative.
They're going down. So what correlation is that, Connie? Negative. When our points are going down, it's a negative correlation. Alright, so do we want to do out of 60, 61, and 62, which 2 do you want to do?
60 and 62.
60 and 62, okay. Is that 60? 60, okay. So 20, 14, and 2, and I need to figure out whether or not it's arithmetic, find my common difference, and my next 3 terms. So what do I do to get from 20 to 14?
Subtract 6.
Came from 14 to 8.
6. And subtract 6.
Okay, so is this arithmetic?
Yes.
Yes. All these numbers are the same, so yes, it's arithmetic.
4.
So then if I keep finding my next 3 terms, 2 minus 6 is negative 4. Negative 4 minus 6 is, and negative 10 minus 6 is negative 16. Okay, so you should tell me, yes, it's arithmetic. The common difference that you found was minus 6, and your next 3 terms were negative 4, negative 10, and negative 16. Okay, and then we said 62. So if I look at 62, I have negative 8, negative 5.5, negative 3, negative 0.5. So what do I need to do to get from negative 8 to negative 5.5?
Add 2.5.
At 2.5. 2.5 came from negative 5.5 to negative 3. What do I need to add? 2.5. And from negative 3 to negative 0.5, what do I need to add?
2.5.
2.5. Okay, so is this arithmetic? Yes, all those numbers are the same, so yes, it's arithmetic. So then we find my next three terms. So what's negative 0.5 plus 2.5? 2. And 2 plus 2.5 is 4.5, and 4.5 plus 2.5 is 7. So you should have, yes, that's arithmetic. Your common difference is plus 2.5, and your next three terms are 2, 4.5, and 7. Alright, for 63, we're finding our 18th term. You have to know this formula for your test, so put it on your note card. To find your nth term, you use a sub n equals a sub 1 plus n minus 1 times d. That needs to be on everybody's note card. So it says we're finding our 18th term when a sub 1 is negative 4 and d equals 6. So what's my n then? That's the only thing I don't know. What's my n? 18. Yeah, 18 is your n. N is the number of term you're looking for. So if we're looking for my 18th term, then n is my 18. So then a sub 18, which just means my 18th term, equals a sub 1. What was my a sub 1? Negative 4, okay, plus n minus 1. What was my n? 18 times my common difference. What's my common difference? 6. Okay, now this is a simple arithmetic problem. 18 minus 1 is 17. So I end up with negative 4 plus 17 times 6. What's 17 times 6? And 2. 17 times 6 is 102. And what's negative 4 plus 102? 98. So my 18th term would be 98. Alright, if I look at 64, tell whether the given ordered pair satisfies a linear function. What does it mean to be a linear function? What word is in linear?
Line.
Line. So what does it mean to be a linear function?
Straight line.
Straight line. Okay, so we're going to look and see if this is a straight line. So we need to find our common differences. Not on this one. You're going to graph on the next one. Okay, so what do we do to get from negative 3 to negative 1? Add 2. And negative 1 to 1 is add 2, and 1 to 2 is add 2. So that's all good, right? All those are the same. Okay, what do I do to get from 3 to 1? And from 1 to 1? 0, and from 1 to 3? Add 2. Is that the same?
No.
No, so then this is not linear. Okay, on 65, we're asked to see if the following equation is linear, and if so, graph it. Y equals negative 5x plus 1. Does this have any exponents? No, it has no exponents. There's no numbers up here or up here. Since there's no numbers up there, then we say that yes, it is linear. If it has no exponents, it is a linear function. So then it asks us to graph it. So we're going to make a table of values. So what do we want to use for our x's? 1, 2, and 3. Okay? So if I use 1, 2, and 3, I plug in 1. Negative 5 times 1 is
5.
negative 5. Negative 5 plus 1 is negative 4. If I plug in 2, negative 5 times 2 is negative 10. Negative 10 plus 1 is negative 9. And if I plug in 3, negative 5 times 3 is negative 15 plus 1 is negative 14. Very good. So we're going to graph that. Okay. So if I graph that, 1, negative 4 is over 1, down 4. 2, negative 9 is over 2, down 9. 3, negative 14 is way down, and we're not going to graph that part.
Yes, we do.
So do we connect our points? Yes, we connect our points because it did not give us a domain to form a line. And that does, if we look at it, form a straight line. So we know it's linear that way too. We can only do 166. 66. Do you want to do the first one or the second one? Second one, okay. 3x minus y equals 9. Find our x and y intercepts. So to find my x-intercept, what do I know about y at my x-intercept? What do I know y equals? 0, right? At your x-intercept, your y is always equal to 0. So if that's true, and I plug in 0 for y, 3x minus 0 equals 9. I can then just ignore that minus 0, right? It goes away. So 3x equals 9. Now what? Divide by 3, divide by 3. So what does x equal? 3. So my x-intercept is 3. If I go to find my y-intercept, what do I know about x and my y-intercept?
X is 0.
X is 0. So I'm going to plug in 0 for x. So 3 times 0 is
0.
0. So I get 0 minus y equals 9, which means I can ignore the 0. So I get negative y equals 9. What number is in front of this y?
1.
1. So this is like negative 1y. So then what do I do to solve?
Divide
Divide by negative 1, divide by negative 1. What does y equal then?
negative 9.
Negative 9. Okay, we're going to skip 67 because it didn't copyright, so you can't see the line, so you can't find it. So then we are almost done. If we go to 68, we're finding rate of change for the data in the table. So we're going to use our first point and our last point, and we're going to use our slope formula. So put this on your our slope formula is y2 minus y1 over x2 minus x1. Okay, so then my first point is my x1, y1. That makes sense. First point becomes your 1s. Your second point then is your x2, y2. Oh, this is supposed to be 256 also. It's a typo on my end. Okay, so then my y2, which is 256, minus my y1, which was 0, over my x2, which is 4, minus my x1, which is 0. So 256 minus 0 is 256. 4 minus 0 is... Does anybody know what 256 divided by 4 is? 64. 256 divided by 4 is 64. So your rate of change is 64. So any questions on 68? Okay, we're going to do 69 and skip 70. So if I look at 69, find the slope of the line for 2x minus 3y equals 6. Slope is the number in front of your x. What number is in front of my x?
2.
2. So your slope is 2. Is easy. That's it. Alright, so I was going to skip 70 because 70 is the same type of question, so it's easy. So if I go on to 71, find the slope of the line containing these points, 1, 2, and 2, negative 3. So this is x1, y1. This is x2, y2. And I'm going to use my slope formula. So y2 minus y1 over x2 minus x1. Connie, will you write this one on the board? Alright, so we get negative 3 minus 2 and 2 minus 1. And that simplifies, no, you're going to finish it, to negative 5 over 1. What is negative 5 over 1, guys?
Negative 5.
Negative 5. So your slope on that one would be negative 5. Yay, thank you, Connie. Yay, 72, we're almost done. Tell whether the equation represents a direct variation. If so, identify the constant of variation. This is your next formula that's going to go on your note card. It's your direct variation formula.
Try to squeeze off.
You write on the back.
I am writing on the back.
Oh, okay, sorry. Your direct variation formula is y equals mx. That's it. So is that in the form y equals mx?
Wait, what is your direct one?
Direct variation. So then if it's in the form, then we would say, yes, this is a direct variation. What is my constant of variation, my m? Negative 6. Easy peasy.
No, it's not.
So 173. Is this in that form?
No, so then you don't have the M.
No, so then you don't have an m.
Graph one.
Okay, so if I look at 74, graph the line with the slope, negative 4 over 5, and y-intercept 6. Write the equation of the line. So I have a slope and I have an intercept, so I'm going to use slope-intercept form. Slope-intercept form is y equals mx plus b. So then m is my slope, and b is my y-intercept. So if I have that equation, y equals, what was my m?
4/5, negative 4/5.
Negative 4/5. Okay, Niles, what is my b? Okay, so y equals negative 4/5 x plus 6. So now we have the equation. That's the second part. The first part is that we have to graph it. We always start with the point we know. So I know that I have a point on my graph at a y-intercept of 6. So on my y-axis, I'm going to go up 6, and I'm going to put a point. So on your y-axis, you should go up 6, and you should put a point. The second thing I know is that slope is rise over run. So that tells me that I'm going to go down 4 over 5 to get to my next point. So from this point that I already know, up 6, I'm going to go down 4 and then over 5, and I will have another point. Yep, and then we do connect our points to form a line. Yeah, you guys want me to skip 75 then? You feel good? You want me to do 75, Niles? Okay, so then 76, write the following equation in point slope form. So we need to know what point slope form is, right? So point slope form is y minus y1 equals m times x minus x1. So I'm given a slope, which we use the letter m to represent slope, of -4. And then I'm given a point -1, -1. So then this is my x1, this is my y1. So y minus -1 equals m. What's my m? -4 times x minus my x1, which is -1.
Have to fix the negative minus positive.
Yes, very good. So we have to fix these minus negatives, and they change to positives. So we actually end up with y plus 1 equals -4 times x plus 1. So any questions on 76? Okay, so we'll go on to 78. So on 78, it says identify which lines are parallel. What do we know about parallel slopes? They don't touch, okay? So if our lines are parallel, then we know that our slopes have to be the same. So we have the same slopes. That's what we know about the slopes of parallel lines. So if I'm looking for the same slope on my parallel lines, let's identify my slopes. On line number 1, what's my slope?
1.
Okay, Niles, what's my slope on line 2? Okay, Kyle, what's my slope on line 3? -1/3. Okay, and Kalani, what's my slope on number 4? There isn't 1, okay, so what number would we use for there? Is it 1? 0. So my slope's going to be 0. Since there's no x, your slope is 0. Okay, so if we're looking for slopes that are the same, what two lines have slopes that are the same, Ethan? 1 and 3. Okay, so any questions on 78? Okay, 79, we're looking for perpendicular slopes. So
they cross. Or no,
yes, they are opposite. They cross at 90 degrees, so they are opposite reciprocals. And who remembers what reciprocal means? Flip around fraction. Okay, so if I have a number like 4, that's the same thing as like 4 over 1, and so what's my reciprocal? 1 over 4, very good. And so then opposite means that one's positive, one's negative. So they have to meet both criteria. So Kyle, if we look at number 1, what's my slope? -5. Okay, Niles, if I look at number 2, what's my slope? 1/5. Okay, Tam, if I look at number 3, what's my slope? Don't have one, so 0. And Ethan, if I look at number 4, what's my slope? 5. Okay, so 5x, so 5. Okay, so Connie, which numbers in there then are positive and negative? Okay, number 1, number 2, and number 4, right? Because 0 is positive or negative. So we've got 1, 2, and 4. So we can ignore 3. We know we're not going to have 3 because nothing in there has anything to do with a 0 slope. Okay, then we have to identify reciprocals. So which ones are reciprocals? So 1 and 2, right? So we have -5 and we have 1/5. So one's negative, one's positive, and now the fraction's flipped over because this is like 5/1. So then we would say that 1 and 2 are going to be our perpendicular lines. Okay, we're going to skip 80. Do you want to do 81 or 82? 82, okay. Alright, so if we skip way to 82, it says graph f of x and g of x, then describe the transformations as either reflections, rotations, or translations, and how they're transformed. Okay, so reflection. What happens on a reflection of a graph? Okay, so yeah, it's on the other side. It's the opposite. It's flipped over. Okay, what happens on a rotation of a graph? It rotates. Okay, what does it mean to rotate? So it kind of like twists. It's like taking the graph and kind of like twisting it in either direction. Okay, what happens on a translation? Just moves up or down. Very good. Okay, so now that we have those straight in our minds, then let's go ahead and graph these so we can identify which one is which. So what values do you want to use? Well, actually, I'm going to pick them this time. I'm going to use -1, 0, and 1 for both of them. Okay, so if I plug in -1 to 4x, it'd be -4. If I plug in 0 to 4x, what do I get? If I plug in 1 to 4x, what do I get? 4. Okay, so my first graph, I'm going to go back 1, down 4. Then I'm at 0, 0, and then the over 1, up 4. And then you do connect those lines. Okay, if I go look at my second one, -4x. If I plug -1 into -4x, what do I get? Positive 4. And if I plug in 0? And if I plug in 1? -4. Okay, so then I'm going to go back 1, up 4. I'm going to go to 0, 0, and over 1, down 4. And then connect those. So there's my second graph. So to identify what type of translation this is. So what type of translation is it? It's a reflection. It kind of looks like a rotation, but this one is a reflection. Alright, so we'll take our final tomorrow. Please make sure you're on time. You can use a note card, a pencil, and a calculator, okay?